Look up. On any given night, humanity finds its celestial anchor. The moon is our planet's eternal companion, a silver eye watching the slow, chaotic bloom of civilization. It is the one constant in our sky, a universal symbol of serenity, mystery, and time itself. From the first hominid to gaze in wonder, to the poets who spilled ink in its name, the moon is the mirror to our world. But what if that mirror is lying? What if the serene, familiar face we know is a disguise? I don't mean a hoax built in a studio. I mean a geological mask, concealing a violent history and a profound, cosmic secret. What if the moon we think we know is only half the story, and the other half is a secret it keeps perpetually hidden from Earth? This is the man in the moon, the face of our homeworld satellite. We call its vast, dark patches the Lunar Maria, or seas. These are not water, but immense, ancient plains of hardened volcanic basalt, the scars of an ancient, fiery youth. This near side is relatively flat, its crust comparatively thin. This is the moon of Armstrong's first step, the one that pulls our tides and lights our nights. For all of human history, this was the only moon we knew. Then, in 1959, the Soviet Luna 3 probe flew behind it, and humanity saw the far side for the first time. It was an alien world. There were no familiar seas, no man in the moon. Instead, we found a rugged, brutal landscape, choked with craters upon craters, dominated by vast, mountainous highlands. Most baffling of all, its crust is inexplicably thicker, in some places by more than 50 kilometers. This is not a minor variation. It is a profound, night and day difference. Planetary scientists call it the lunar farside highlands problem, or more simply, the lunar dichotomy. It is, without exaggeration, one of the greatest unsolved mysteries in our solar system. How can one single spherical body be so fundamentally two-faced? It's as if you cut two different planets in half and welded them together. The standard story of the moon's birth struggles to explain this. We are told of the giant impact hypothesis, a young, molten Earth struck by a Mars-sized planet named Theia. This cataclysm blasted a ring of molten rock and vapor into orbit, which coalesced to form our moon. It's an elegant, powerful theory, but it has a gaping hole. How does one homogeneous debris cloud, spinning and cooling, create one moon with two completely different geologies? This question is not just academic. The moon is our partner. Its massive gravity stabilizes Earth's axial tilt, preventing the wild climatic swings that would have made complex life impossible. It gives us our seasons, our tides, and the rhythm of our planet. To understand how the moon became the object it is to understand the very origins of our own world. If we cannot explain its most basic, glaring feature, what do we really know about the forces that shaped us? This is where our investigation begins. Because this radical asymmetry, this two-faced riddle, isn't a flaw in our models. It is the model. It's not a paradox. It's a piece of evidence. It is a scar, pointing to a past more violent and more bizarre than we could have ever imagined. What if the answer to why our moon has two faces is that it's not one object at all? What if the rugged, cratered far side is the corpse of a second moon, and the face we see every night is its tombstone? To find the ghost of the second moon, we must first return to the scene of the crime. We have to rewind the clock, not by centuries, but by eons. Our journey takes us back 4.5 billion years, to the very dawn of our solar system. This is not the orderly, predictable system we know today. It is a violent, chaotic construction site, a cosmic shooting gallery where planets are not yet planets, but protoplanets, massive molten bodies colliding in a gravitational free-for-all. Here we find our young Earth. It is not the blue-green marble of our photographs. It is a hellish forge, a sphere of molten magma and boiling rock, glowing red-hot in the dark of space. It is a world still reeling from its own violent birth, a world without oceans, without air, and without life. It is a planet in the process of becoming, but it is not alone in its orbit. Another world is approaching. We call it Theia, named after the Greek Titaness who was the mother of the moon goddess. Theia is a rogue planet. It is a wanderer from the outer system, a planetary embryo roughly the size of modern-day Mars, locked in a deadly, converging dance with our own. Its approach was not swift. It was a slow, gravitational spiral that may have taken millions of years, an apocalypse drawing nearer with every single orbit. And then the inevitable. Theia strikes. This is not an asteroid impact. It is a world colliding with a world. Theia, traveling at tens of thousands of kilometers per hour, doesn't just hit Earth. It plunges into it. The collision is off-center, a glancing blow of unimaginable power. The energy released is beyond human comprehension. It is 1 billion times more powerful than every nuclear weapon on Earth detonated at the same instant. It is an explosion that liquefies both planets. In a single, horrific moment, the crust and mantle of both Earth and Theia are vaporized. Theia's dense iron core plunges through Earth's molten mantle to merge with our own. The young Earth, now superheated to thousands of degrees, becomes something new, something terrifying. It becomes a synestia, a vast, spinning donut-shaped cloud of molten and vaporized rock. Its surface no longer solid, but a glowing fog of silicate vapor expanding into space. This is the immediate crime scene. But the true evidence is what was thrown clear. The impact was so violent that it blasted a plume of this vaporized rock, trillions of tons of Earth's and Theia's mantles, into orbit. This was not a ring of icy pebbles like Saturn's. This was a glowing, boiling, incandescent torus of magma, orbiting the wounded molten Earth at a furious speed. It was a ring of fire that would have lit up the solar system. This is the giant impact hypothesis, and it is the bedrock of lunar science. It elegantly explains why the moon's chemistry is so similar to Earth's mantle, yet why it lacks a large iron core of its own. The standard theory tells us that this glowing ring of debris, over the next few thousand years, began to cool and clump together. Gravity, the great sculptor, pulled these molten moonlets into a single massive body. This body became our moon. It's a beautiful story. It's clean, it's tidy, and it has been the accepted wisdom for decades. From ultimate chaos, a perfect, singular creation. A single cataclysmic event gives birth to a single stable partner that will one day foster life on the planet below. It's a narrative that appeals to our human desire for order. But what if the universe is not that simple? What if chaos does not so easily surrender to simplicity? What if a collision that massive, an explosion that remade a world and filled the sky with fire, didn't create a single tidy child? What if the sheer scale of the debris cloud, the boiling, churning violence of that molten ring, was too complex for one simple outcome? What if the standard story is missing a character? What if that single ring of fire didn't just give birth to one moon, but to a family? This brings us to the very heart of our investigation. The giant impact theory is not wrong. It may simply be incomplete. The evidence of the lunar dichotomy demands we look deeper, and the moment we do, a stunning hypothesis emerges, one that rewrites our planet's origin story. The Theia impact did not create a single moon, created two. For a time, in the dim red twilight of the Hadean Aeon, Earth was a two-moon planet. This was not an identical twin. Our main moon, let's call it Luna for clarity, was the dominant sibling. It formed rapidly, a massive gravitational bully sweeping up the lion's share of that molten debris ring. But it wasn't perfectly efficient. In the chaos of that orbital cloud, a second, smaller child was born. This lost sibling would have been a substantial world in its own right, perhaps a third the size of Luna, or roughly 1,200 kilometers across. It was a leftover, a cosmic runt of the litter. But how can two moons share the same orbit without eventually colliding? This is where the story moves from brute force to celestial mechanics, a dance of perfect gravitational balance. In the 18th century, the mathematician Joseph Louis Lagrange discovered that in any two-body system, like the Earth and its new large moon, there exist 5 hidden stability points. These are gravitational safe zones, cosmic parking spots where the pull of the two larger bodies perfectly balances the centrifugal force of an object's orbit. These are the Lagrange points. While 3 of them are unstable, 2 of them, known as L4 and L5, are profoundly stable. They lie 60 degrees ahead of the Moon and 60 degrees behind it, forming a perfect equilateral triangle with Earth and Luna. Any debris that found itself in this gravitational sweet spot would just stay there. It wouldn't fall to Earth and it wouldn't be captured by Luna. It would be perfectly, peacefully parked. This is the hypothesis. As the primary debris cloud coalesced into Luna, a second, smaller concentration of material gathered in the L4 or L5 stability zone. It formed from the very same molten rock, a true sibling from the same cataclysmic birth. This Trojan moon was born. It orbited our planet at the exact same distance and the exact same speed as its larger sibling, a silent companion trapped in a perfect gravitational equilibrium. It was the Earth-Moon system's hidden secret. So, what would you have seen standing on the cooling crust of that primordial Earth? You would look up into a reddish, dusty sky and see our main moon, Luna. Back then, it was 10 times closer to Earth, a monstrous, glowing orb dominating the heavens, its magma ocean still cooling. But it wouldn't be alone. Trailing it, or perhaps preceding it, would be a second, smaller moon. It would have appeared as a brilliant, steady star, a morning star that never set, forever chasing or being chased by its big brother. This wasn't a fleeting arrangement. The laws of celestial mechanics tell us this configuration would have been stable. For millions, perhaps even tens of millions of years, this was the normal for planet Earth. It was an age of two moons. Our world spun through the dark, accompanied by its two children, one large and one small, forever keeping their silent, respectful distance. A celestial family, born from fire, and settled into a delicate, geometric peace. It is a profound, almost romantic image, a lost era of symmetry in our sky. But as we look up today, our sky is empty of this companion. The L4 and L5 points are now just barren patches of space, home only to dust. This peaceful equilibrium, this age of two moons, was not destined to last. It was a temporary armistice in a chaotic system. And this leads to the obvious tragic question. If this lost sibling truly existed, where did it go? For tens of millions of years, this celestial dance endured. The young Earth, its massive partner Luna, and its smaller Trojan sibling, held in a perfect, stable triangle. It was an age of equilibrium, a brief moment of geometric grace in a violent universe, a vision of a sky that no human eye would ever see. But in the grand arena of the solar system, no peace is built to last. There was another, far more powerful gravitational player on the field, the Sun. And as our main moon, Luna, slowly spiraled away from the Earth, a process that continues to this day, that perfect balance began to waver. The Sun's immense gravity was a constant, unsettling presence. It plucked at the delicate threads of the Earth-Moon Trojan system, introducing subtle, chaotic perturbations that slowly accumulated over the millennia. Those Lagrange points, those stable parking spots, are not deep gravitational wells. They are more like shallow divots on a vast, vibrating surface. The Sun's relentless gravitational nudging, combined with Luna's own outward migration, was the finger that slowly, relentlessly, pushed the pebble from that shallow divot. The perfect balance was broken. The fall from grace was not sudden. It was a slow, agonizing drift that lasted for thousands, perhaps millions of years, a creeping doom written in the cold equations of physics. The smaller moon, its orbit now unstable, began a long, looping spiral, its path becoming more lopsided and eccentric with every single pass. It was a phantom, unmoored from its celestial anchor. It was now being pulled inexorably toward the one place it could not escape, the massive, waiting gravitational embrace of its larger sibling Luna. The siblings, born of the same fire, were now on a collision course. We must erase from our minds the typical image of a cosmic collision. We think of a high-velocity asteroid, a blinding flash of light, a fiery explosion that excavates a crater hundreds of miles wide. This was something entirely different, something more intimate and, in its own way, more terrifying. This was an apocalypse in slow motion. Because the two moons were born from the same event and shared the same orbital neighborhood, their relative speed was not high. One wasn't a bullet striking a target. It was a slow, massive pursuer in a cosmic chase that was finally, inevitably, coming to an end. This is the event scientists call the Big Splat. When the smaller moon in its chaotic new orbit finally caught its partner, it was moving at a mere 2 to 3 kilometers per second. In human terms, this is hypervelocity, but in the physics of planetary impacts, it's a gentle cosmic fender bender. It was not nearly fast enough to vaporize rock on a massive scale or blast a colossal, recognizable crater that would erase the evidence. Instead, the smaller moon pancaked against the larger one, spreading its material out like a thick, viscous liquid. Imagine a bullet made of soft clay hitting a bowling ball, but on a planetary scale. At this relatively low velocity, the impactor doesn't excavate. It accretes. It splatters. The smaller moon, a 1,200-kilometer wide world, effectively smeared itself across the surface of Luna. It was less of an explosion and more of a cosmic landslide, an entire world flowing like a slow-motion wave of rock, crust, and mountains across one hemisphere of the larger moon. This is the crucial finding of the computer simulations that first proposed this revolutionary idea. In a matter of hours, it was over. The lost sibling was gone, its independent existence erased from the solar system. Its body, its mountains, its craters were completely and permanently incorporated into its twin. Where there had been 2 moons in Earth's sky, there was now, once again, only one. But it was not the same moon. It was a new, larger, and profoundly unbalanced object, a chimeric world. The second moon was not annihilated. It was added. It became a new layer, a new surface, a new face. This colossal splat was not just an ending. It was a creation. It was the precise moment our moon's 2 faces were forged in a slow-motion fire. This single catastrophic event would send a shockwave through the entire lunar body, a catastrophic rearrangement that would permanently alter its internal geology. The smaller moon didn't just leave a scar. It became 1/2 of the entire body, and the evidence of this ancient, world-consuming event, this cosmic fratricide, is still hanging in our sky, perfectly preserved, waiting for us to read its silent, rugged testimony. We began this journey with a profound riddle, a cosmic mystery etched onto the face of our nearest neighbor. Why the 2 faces? Why the stark, brutal difference between the flat, dark plains we see and the thick, mountainous fortress it hides from us? The Big Splat hypothesis is so powerful because it is not just a story. It is a precise physical mechanism. It is an explanation that predicts, with stunning accuracy, the very enigma we're trying to solve. The evidence for the lost moon is the moon itself. Let's return to those rugged alien highlands on the far side. Why is that crust so inexplicably thick, in some places more than 50 kilometers thicker than the near side? The Big Splat model provides a stunningly simple answer. That crust is the second moon. Because the impact was a low-velocity splat and not a high-speed blast, the smaller sibling wasn't vaporized. It accreted. Its entire rocky mass, a world 1,200 kilometers wide, was smeared across one hemisphere of Luna. The far side highlands are not just mountains. They are the compressed, fossilized remains of a consumed world. A planetary collision, even a slow-motion one, is an event of unimaginable violence. It doesn't just add a layer. It sends a cataclysmic shockwave through the entire victim. And this is the key. At the time of the impact, our main moon was not the cold, solid rock we see today. Beneath its thin, solid crust, it concealed a vast, global ocean of molten magma. This wasn't just lava. It was a unique chemical soup. Planetary scientists have a name for this internal magma layer. They call it the KREP layer. It's an acronym for a bizarre concentration of elements. K for potassium, REE for rare earth elements, and P for phosphorus. What makes these elements so important is that they are incompatible. They resist being locked into solid crystals, so they stay in the molten part. Crucially, this brew is also packed with radioactive elements like uranium and thorium, which generate an enormous amount of heat. This KREP layer was the moon's hidden, radioactive furnace. Now let's replay the impact. The smaller moon splatters against the far side. That colossal, slow-motion hammer blow sends a shockwave through the moon. What happens to the liquid magma ocean inside? It sloshes. Like hitting one side of a water balloon, the impact shoved this entire global ocean of molten, heat-producing KREP to the opposite hemisphere. The far side collision caused a catastrophic, internal tidal wave. It concentrated almost all of the moon's radioactive fuel into one place, directly beneath the thin crust of the near side. This solves the second half of our mystery. It perfectly explains the man in the moon. The near side became a giant radioactive hotspot. With this immense furnace of KREP concentrated just below the surface, the crust was cooked from beneath for hundreds of millions of years. This intense, localized heat fueled supervolcanoes on a scale we can barely imagine. Magma erupted and poured across the surface, flooding the giant, ancient craters and basins, drowning them in a sea of black basalt. These are the Maria, the dark seas we see from Earth. And why did the far side remain a rugged wasteland? It was left doubly cursed. The splat had not only plastered it with a thick, insulating layer of extra crust, but the impact had also robbed it of its share of the KREP. Without that internal radioactive furnace, there was no engine for large-scale volcanism. The magma couldn't reach the surface. The crust remained thick, cold, and dead, a silent witness, preserving its ancient craters instead of drowning them in lava. The theory connects every piece of evidence. The lunar dichotomy is not a paradox. It's a before and after picture, frozen in time. The two-faced moon is the direct, physical, and necessary consequence of cosmic fratricide. The far side is the bullet, or rather, the splat. The near side is the splash zone, the internal radioactive bleeding that resulted from the impact. It is a single, chilling, and breathtakingly elegant solution. The evidence, it turns out, has been painted across our entire night sky, a 3,000-kilometer-wide testament to a lost world. We set out to find a lost moon, and in the end, we find that it may never have been truly lost at all. It's been hiding in plain sight. Science rarely deals in absolute final proof, but in the most powerful evidence-based stories. And the story of the Big Splat is perhaps the most compelling, elegant, and chilling narrative to explain our moon's deepest riddle. It forces us to look up at that familiar silver disk and see it for the first time as a chimera. This is no longer the moon of poets, the symbol of perfect, eternal constancy. It is a monument to a past of unimaginable violence. It is a survivor that consumed its own twin, a composite world welded together in a slow-motion catastrophe. The serene face we see, the man in the moon, is nothing more than the lasting wound of that ancient trauma, the internal bleeding that flooded the surface. The hidden face, the far side, is the tombstone, or perhaps the very body of that long-dead sibling. This reframes our entire relationship with the night sky and with our own origins. We are, all of us, fundamentally children of chaos. We tend to look at the cosmos for a sense of peace, for something permanent and eternal to contrast with our fleeting lives. But our closest companion is a silent, glaring reminder that the universe is not built on serenity. It is built on brutal collision, on creation through destruction, on survival. The moon is not a gentle guardian. It is a fellow survivor, and it wears the scars of its victory for all to see. And here is the final, profound reflection. This act of cosmic fratricide, this ancient, distant tragedy, may have been the single most important event for the future of life on Earth. A planet's habitability is a razor-thin proposition. The moon we have today, this larger, chimeric moon, is what stabilizes our planet's axial tilt. It's the gravitational anchor that prevents Earth from tumbling wildly in its orbit, which would have created climatic swings of unimaginable violence. It is this precise stability that gives us our predictable, gentle seasons, the very rhythm that allowed complex life to crawl from the oceans and evolve over billions of years. Had the Big Splat never happened, we might have been left with a smaller moon, one perhaps insufficient to anchor our world. Or we might have been left with two, their competing gravitational pull creating a chaotic system hostile to life. That ancient, violent merger wasn't just an end. It was the final, critical step in our beginning. We may, therefore, owe our very existence not just to the moon we see, but to the ghost it consumed. We are the beneficiaries of its sacrifice. The lost sibling didn't just die. It became the ballast, the counterweight that locked in the final, stable conditions for our own evolution. The next time you look up at that glowing, familiar face, remember what you are really seeing. You are not looking at one world. You are looking at two.